Good day to everyone. I'm going to present you the seminar called Petrogenesis and Geochronology of Volcanic Rocks from the Sierra San Miguelito Volcanic Complex in Luis Potosí, Mexico. Our study area is mainly located at the south section of the Basin Range province, more specifically in the physiographic province named as Mesa Central in central Mexico. The Mesa Central province is mainly characterized by different fault systems and as well from different types of volcanic rocks, especially from the Cenozoic time. Our area is mainly focused at the south section from the Mesa Central province. The San Miguelito Volcanic Complex is mainly characterized or is mainly composed by different normal fault systems with domino style that cross all over the volcanic complex. As well, this volcanic complex is composed by 7 different types of units that we can enroll or can be grouped in general way, like silicic groups, intermediate groups of rocks, and mafic group of rocks. The silicic group of rocks is composed by different massive lava flows of rhyolitic composition with some deposits from ignimbrites that is composed by the San Jose unit, the Cantera unit, and the Panaleo unit, and the silicic rocks from of lava flows is from the Zapote unit and San Miguelito unit. As well, in some isolated areas from the volcanic complex is located some massive dark porphyritic lava flows from a small scale of outcrops, and mainly from mafic and intermediate composition composed by La Placa unit and Cabra unit, that is mainly mafic rocks and the most youngest unit of the area. The petrographic characteristics from this simple groups of rocks is that the mafic rocks present a mineral assemblage of plagioclase, orthopyroxenes, clinopyroxenes, with some plagioclase that have disequilibrium texture like this one, like chip textures like these ones. On the other hand, the intermediate rocks present some quartz phenocrysts with reaction rims like these ones, as well plagioclase, pyroxenes similar from the mafic rocks, and some olivines that are in a state of oxidation. In the other way, the silicic rocks present a mineral assemblage of orthopyroxenes, quartz, potassic feldspars, especially from subhedral to hedral form. The geochronology made it in the area is mainly focused in argon-argon age, because in previous studies from the area it was only published potassium argon age in whole rock. So what we make is compile that data that is previous reported, then we measure new data from argon-argon age, and we have seen that the San Miguelito volcanic complex is composed by 3 main phases of volcanism that range from the 34 million years to the 22 million years. And these 3 phases is characterized by different style of rocks. In the first phase, we have rhyolitic lavas, domes, and lava flows that are more effusive volcanisms with some explosive volcanisms that is characterized by the ignimbrite units like these ones. And then we have the second episode that is mainly focused in the fusion of intermediate and mafic isolated rocks, that is from La Placa. And then we have a big ignimbrite deposits from the Panaleo unit. And then we have a pause in the volcanisms in the area. It looks like that we have a pause in the area, and then we have as well in isolated area and isolated spots from the volcanic complex and a fusion of mafic rocks that is characterized by the Cara units. Therefore, the geochemical characteristics from the area are that we have rocks from basal and strachy-basal composition, basaltic andesite and andesite composition, and then only rhyolite to the felsic group or the silicic groups in composition. As well, the mafic group of rocks we saw that have an enrichment in light rare elements with a descent in the heavy rare elements with a scase or new negative anomaly from europium that we have over here, and the intermediate group is almost similar to the mafic ones, especially in the trend. On the other hand, the silicic rocks, we have an enrichment more various in the light radar elements with a descent almost horizontal to heavy radar elements with a pronounced negative European anomaly that is, of course, see as well or compare with the petrography where we have big phenocrystals from plagioclase or feldspars. As well, we make isotopes and we compile some information from isotopic information from the basin range subsection or the subsection of the basin range, and we compare with our samples, and we have saw that the mafic sample from the San Miguelito Volcanic Complex trend to a mantle array, and the intermediate and the silicic rocks trend more to a continental cross contribution. Therefore, we have saw that maybe we have two sources or two kind of sources to the Petrogenesis from these three type of groups. Therefore, we propose these two models until now, where we propose that one part of the silicic or the mafic, one part of the mafic group of rock from the San Miguelito Volcanic Complex was derived by a partial melt from a lersolite mantle, and one of part of them could be in contact or can be contributed by a lower cross. Then, in the other hand, middle cross, and the other hand, the silicic rocks we propose that they are derived by a partial melt from intermediate granulite that represent a level of middle cross from the area. And in the other hand, to the intermediate group of rocks, we propose that it was fractionated from a mafic source more similar like this one that we have over here, and then was assimilated to a metasedimentary cross that represent a middle cross from to the area, and then was assimilated. So the main process that was generated to the intermediate rock was a FEC process. As well, the tectonicity from these three group of rocks is not really questionable. It's totally a continental rift that is related as well to the fault system that we have in the area. So the schematic model that we propose from the San Miguelito Volcanic Complex is this one, that we have three different episodes of magmatism. One where the rhyolitic domes and pyroclastic deposits were generated at the 34 to 32 million years. Then we have the extension was occurring in that part of the Cenozoic, and then the extension continued to the 21, 22, and moreover. And in the 32, 28 million years, some intermediate lavas was generated in some parts of the volcanic complex, as well the FEC process was occurring. And then the 22 to 21 million years, the cross was more thinner, and we have some ascent of mafic magmas that we have over here. So, by conclusions, we can see that we can tell that magmatic rocks from the San Miguelito have a wide composition range of basic, intermediate, and silicic rocks. The mafic volcanic rocks were derived from two sources, one derived from the lithospheric mantle, and a second source involves a lower cross component. The intermediate volcanic rocks was derived from a simulation and fractional crystallization process of mafic melts. Felsic volcanic rocks were derived from partial melt of mid-continental cross granulites, and then the volcanism was active during the 34 to 21 million years in three different episodes, and these magmatic rocks of the San Miguelito were probably formed in a wetting plate setting during the basin and range related extension. You can see more information or more details in our two published papers that we have over here. And thank you for your attention.